Okay, so we have a new set of data. So before we do the new material, how about we just go over how to kind of get our calculator out of the old and into the new. So the first thing, probably we can go to Zoom Standard, right, to get our standard viewing rectangle back. And then what we can probably also do, right, is go to y equals and just basically clear the functions that we had in there. So simple enough. And then we can go to the stat and edit, and we can basically just clear our list, right? So highlight, drag that up to L2, press clear, and enter. So now that's cleared out. Moved over, up, highlight L1, press clear and enter, and it's gone. So now the calculator's gone. Even though my stat plot is on, when I go graph, right, it's going to give me dimension invalid because there's nothing in there. So the calculator's saying, hey, what do you want me to do? So we got to go put some data in there. So let's go to stat again. Let me quit out of there. Let's go to stat. We want to edit, and in L1 we want to put this data set. All right. So a new data set to work with. So we have -6, -3, 0, 3, and 6. All right. So there's my X data. Come over to L2. My Y data is -10, and 0, and 4, and 2, and -6. Okay? And before we even do any graphing, right, we're predicting this is not going to be a line because last video or last section, right, the change in X is constant. We're going up by 3, but here we go up by 10, and then up by 4, and then down by 2, and then down by 8. So the change in Y is not constant. So we're not expecting this to be linear at all. But let's go ahead and we'll see that. So I believe our, let's go to Y equals, the stat plot, just to make sure it's on, right? It is on. It's showing me a scatter plot, L1, L2, yeah, so we're good. So when I go graph this, there's the plotted data. And clearly, right, this is not a line, right? As a matter of fact, let me get the glare out of there, right? When you look at that data, it's actually more parabolic than it is linear. So this is going to be quite the joy, right, to fit a line to this when it's not quite linear to begin with. So how do I find a line? So obviously it doesn't seem to be linear, right? Can we pick 2 points to find a linear model? Sure, but it's going to be all over the place. So how about, you know, it looks like it's going up and going down, so why don't we kind of pick something right in the middle? So maybe we pick those 2 points right there, right? So we got -3, 0. Right, and we've got, what is that? Looks like 3, 2. I'm going to use those data points because they seem to kind of model, right, the general. We know it's going up and down, it's increasing and decreasing, but we're trying to get the best fit I generally can. So with that, again, we want to find f of x equals mx plus b. For the data points I chose, I don't have a b, so we're going to have to use this first. Right, our point slope form. For the data that I have, my m would be 2 take away 0 and 3 take away -3. So we get 2 over 6, which is 1/3. So let me go ahead and use this data point there. So y minus a -3 equals 1/3 x minus, oops, that should be 0 there, and that should be -3. Okay, so we get y equals 1/3 x plus 3. And distributing, we get y equals 1/3 x plus 1. So there's my model, right? That's what I'm getting if I use that. Of course, if I used a couple of other points, we get something else. So let's go ahead and graph our line with the data. So I'll go to y equals, sorry about that glare. All right, I'll go to y equals, and I like to use parentheses, so 1 divided by 3, right, times x plus 1, and there's what I think is the best fit. Of course, it's going to go through those 2 points exactly because we use those 2 points to fit the line. But clearly, the data is not linear. It's the calculator's having a tough time doing this. What about the regression analysis, right? Can the calculator give me the best fit? And it sure will, right? So all we have to do again is go to stat. I'm going to calculate. Oops, I keep doing that. Stat. We're going to calculate. We want to do a linear regression. Okay, dang it, that glare. Okay, we're going to do a linear regression. Let me turn that light off. Now it's too dark. Hopefully that's light enough. Right, so we've got that, and then L1's good, L2's good, and then I want to store this regression equation it makes into the calculator already. So just press alpha and the trace button. We want F4, and let's store it in Y2. So I'll just arrow down. Right, I'm going to store it in Y2, and then I'm going to have it calculate. All right, and then the calculator actually looks really, really close to mine. So you can kind of tell I chose a couple of good data points there. So what we end up having, right, their model, right, the regression model is f of x equals, I think it was 0.333, which is just 1/3 again, and then minus 2. So that's their model. Okay, and again, if we graph it, go to y equals. Notice again, there's my model and there's their model. So because I stored it in there, that was a little faster. There's my model and there's their model. It's parallel to mine. So I chose some really good points. I did not prepare that to begin with. I just was taking a guess there. So me and the calculator agree on the slope. We disagree on where the y-axis is. But in terms of distance, right, the distance between this point in the line, this point in the line, and these points in the line, right, that's the minimal distance throughout. That's why we call it a linear regression. It's actually called the method of least squares, but I'm getting way advanced for our course. So that's why their model is actually better than mine. It truly is the best fit for something that's not even linear to begin with. So there's that model. Again, we can use both models to predict, right, what would f of 10 be. So again, if we use just by hand my model, right, we're going to get 10/3 plus 1, and that's basically 10/3 plus 3 over 3. I'm expecting 13/3 out of that, which is 4 1/3. To use the regression model, right, we're going to take 1/3 times 10 and minus 2, and that'll be 10/3 minus 2, which is 10/3 and 6/3 and 4/3. So they're going to get 1/3. So going to this, again, we probably want to mess around with our window. Let's move it out a little bit. So I'm going to go window. I want my x max, so let's go out to 20. And I think that'll be good enough. So there's the graph, there's the data, there's my fit, there's the graph's fit, and if we go to calculate a value at 10, right, first it's showing what my value is for my function, and it's right where I predicted it, 4 1/3. Arrow down, it's now sitting on the regression analysis function, and it's basically, that's 1/3 x minus 2, and it's giving us 1 and 1/3, or 4/3. So my math and the calculator are all matching up, and that's what should happen. This is a tool, it's a great tool, but mathematically we should know what's going on, because if we don't, it's not a very good tool. Right? So hopefully that helps you a little bit more about how to use the stat feature, how to use the linear regression analysis, and how to do some predictions, whether it's with our function or with the graphs function, both algebraically and then pressing buttons. All right, we'll do one more just to practice and make sure we're perfect. See you guys in the next video.